Hello and welcome to this tutorial on Infor Data Lake Query APIs. If you're a user of the Infor Cloud, you may be wondering how can I get access to my data from my applications programmatically through RESTful APIs. The Infor Data Lake, of course, is the repository that applications replicate their data into. And so it makes sense that if you want access to those application data, that you'd want to access the data lake and probably programmatically from other applications via RESTful API. So we're going to go through how to do that today. There's a few steps. First is to explore and test those APIs in a browser to make sure they're working the way that you expect. Then to set up your app as an authorized application in the API gateway. Then to connect your apps programmatically to those APIs. Steps 2 and 3 have already been covered in other videos, and those links should be appearing in your browser right now. So I'm not going to cover that part again for you. You can refer to those other videos. What we're going to focus on is step 1. And so as part of that step 1, we're going to take the role as an administrator, and we're going to use Ion Desk to go in and view what's in the data lake. Then we're going to use that same administrator role to go into the API gateway in the browser and view the APIs there and test them. And then that last step, of course, and that number 2 and 3 will be then for you to go in and connect your app to those same APIs that we have explored and tested. Let's go ahead and get started. I've logged into the Infor portal. I've landed on my home page, and I'm going to switch over to my Ion Desk administrative tool. I'm going to go into the menu and choose Data Lake, Compass. Compass is our tool for making SQL-based queries through a browser into the data lake. So for this example, I'm going to choose WFM employee object. And I'm going to be using the workforce management, the WFM system for this demo, but just know that whatever type of objects you have in the data lake or wherever they came from, this tutorial and the tools I'm going to show you work for any of them. I just happen to be using this system for the demo. So I can see that the WFM employee object does exist in our data catalog. And to get started with my SQL, I can actually go into the SQL helper here and do a select statement. And it'll generate a select statement using the metadata that it's pulled out of our data catalog to just query every single field in that object. If I wanted to be a little more robust, maybe I would choose this SQL select, including additional properties. And I'll show you why in just a second. But I'm going to do a select star from WFM employee, but it's going to include this little modifier at the top. And when I run the query, you can see that it returns the top 100 rows. It's not going to actually show all the data just for performance reasons. It's going to give me, this is just a preview or a kind of an ad hoc querying tool in the browser. So it's going to show me the top 100. But I can see that all those fields that are shown over here from the data catalog are included in the records. I can see the data that's actually in the records. And then towards the end of the file, you'll see some Infor dot fields. These are fields that are added to the original record to store metadata about the record in the data lake. So a data object ID, which is important, we'll talk about in just a second, and the Infor last modified fields we'll talk about as well. Those two are of specific importance for the rest of our session, but you can see a couple of other fields here have been added. Otherwise, this record is exactly the same as the fields in the database from the original system, okay, from the original Infor system, in this case WFM. It's only these fields that are added to it to hold this metadata. All right, now that we've seen this, let's jump right into the APIs and see how they work. So I'm going to go into the Ion API gateway. I'm going to search for the Ion set of APIs. And over on the second page, there are data lake APIs. So I'll go into the Swagger documentation, also known as Open API specification. Whichever name you use, just know that this is a standard way to show and document RESTful APIs. It's an industry standard, and Infor uses this. So for those of you who've used REST APIs before, it should look familiar. The APIs we're going to focus on for the data lake are these first two sets, the Compass APIs and the Payload APIs. The Compass APIs, as you might expect, correlate back to that Compass tool that we just saw in the administrative UI. It is a way to query the data lake via an API using SQL. So for example, if I go into this first post API, and you can see by the description, it is for submitting a Compass SQL job. There's only one required input, and I can click the Try It Out button. And if I jump back to my Ion Desk screen for just a second, I can actually select this, copy it, and paste it into my other screen. So I will do that, select, because I know this is a working SQL query, right? I've already tested it in the browser, so I can use it now in my API call. All right, and go ahead and do that and get a result. Now, as you build out your programmatic way to extract data out of the data lake, you may say, well, this is great, Keith, for my initial load. I want to get everything out of a given table or everything for a given object. But what happens for the second call? I only want the deltas. I only want what's changed since the last time I extracted. You can do other SQL functions, including where clauses and joins. And so I could do this and put in a where clause and say I only want to get things after a certain date. And this might be the timestamp of the last time that I queried the data lake. I'm going to go ahead and submit this. I can choose which format it comes back in. I'll just leave the default, which is CSV, and hit execute. What it comes back with is a curl statement here in case you're a programmer and you want to run this from the command line and get some results. But it also gives me the actual result, which is a 202 response back saying your job is running. And more importantly, it tells me my job ID. This is going to be kind of a multi-step API call to get all my data out. So the first step was to submit the job, then to grab that query ID from the response, then to go back and do the status call through another API and put that ID in it so we can check to see if the job is complete. We can see, by the way, in the help that the job goes from a running status to a transforming status to a finished status. And it's that finished status that I'm looking for. You can see it's in the middle of the job, that transforming status. But if I run it again, there we go, it's finished. And now I'm ready to take that same query ID and actually get my data from the query, which is the result API. So I'm going to click the Try It Out and put in the same ID, hit execute. And now you can see in the response, I've got a 200 back and I've got a CSV formatted response, first of my headers, my field names, and then of the actual data for each record. And I think there's over 100 records in here. And so I know that it's working. And so now as a programmer, I've got the whole package. I've got the APIs that I need to use. I've got the SQL format has been tested. Everything I know is working in the browser. I can take this and now use this in my code and use it programmatically. What if you don't want to use SQL? What if, for example, you want a little faster way? Because as you could see there was a little bit of a performance issue. I had to wait a few seconds to get my response back. I had to go through a transforming step to go from our native format in the data lake, which is JSON, and transform it back into the SQL CSV format to come back. And so if I was doing thousands and thousands of records, maybe millions of records, and I was doing multiple objects, that time that it took to do those transformations may not be appealing to me. And maybe if I'm an advanced programmer, I don't need to use SQL. I can use the native query language. If that's the case for you, then you can use the Payloads API. So right here we can see the version 1 Payloads API. We can use the stream by filter to accomplish something very similar to what we did in the SQL statement. Here you can see that there's several possible input parameters, but what we're really looking for with a simple test is to use the filter. Now you can see in the help here that the filter parameter said that the syntax is identical to the payloads list API. So if I go up here to the payloads list, which doesn't get me the actual data out of the data lake, it just lists the objects that would be returned that match my query filter. It gives me some examples of the syntax that are very helpful. So you can use this kind of syntax definition with all these examples here and different properties I could query in this payloads list API to use in the stream by filter. So for example, using that native syntax, I could put a query in like this. I want to look for a document name, which is the object name that we saw before of WFM underscore employee. And I want to use a DL document date, which is the same as that timestamp date we saw back in the Compass query. And I can put in a range of the same time, the first of this year up until 100 years from now, and get the delta since the last time that I queried. I can hit execute, and you can see I got a 200 HTTP response back. And you can see that the data coming back is going to give me some of that metadata again, tell me about the first record. And then it's going to give me the first record in a compressed or a deflated format. And then it's going to give me metadata about the second record and then give me the second record in a deflated format. Why does it do that? Again, this API is meant for speed and efficiency, so we're compressing all the data and trying to save bandwidth back to your application that's calling this. It's going to keep giving me all the records that I want in one payload response back. I could download this if I wanted to, but it's not going to be usable because I'm viewing this in text format and this is compressed. But if you call it from your program, you'll be able to pull it back in the native format and then run your decompression code against it. If by chance you're querying tens of thousands of objects, you're retrieving lots and lots of data from the data lake, there is a split query API. And this split query API will give you 10,000 results at a time. So it's a multi-part stream. So you'll make this query and then it'll give you IDs to call back and say, okay, give me the first 10,000, give me the second 10,000 and another call, give me the third 10,000 and another call. And by doing that, that kind of splits up. If you have experience with RESTful APIs over the internet, you typically don't want to stream a really gigabytes of data, really large sets of data in one call. You'd want to split it up into multiple parts. And so that is possible as well. As you can see here, the Swagger documentation is very helpful in exploring these APIs and making sure that they work as you would expect. And then once you have this working, you can go into your programming environment and actually use them. Hope you enjoyed that tutorial. For more information, much more information on how to do this, you can view the Ion Desk Administration Guide. In particular, the Ion Development Guide will go into greater detail about these APIs. And of course, our own Infor campus for in-person and more in-depth training is available to you as well. Thanks for watching.